Alright class, so we started talking about equilibrium. To kind of summarize what we talked about last time, which is some reactions, they never go to completion. Then what happens is, at some point, they reach equilibrium. Now what does that mean again? So I put an example up to explain it one more time. So let's say at the very beginning, I have nothing but N2O4. So at the beginning, this reaction is mostly going this way pretty fast. At some point, this is going to slow down, and as I'm forming more product, then the product is going to start going back. So again, it's this going back and forth at different rate. At some point, we reach equilibrium. So this is going at the beginning, this is going fast, then it's going to slow down. At some point, the reactant is going to be pretty fast, going backwards until we reach equilibrium. When we're in equilibrium, then we have stabilized. We've reached a stable state. And in that stage, when we reach the equilibrium, then the rate of going forward and backward are equal. We've reached a stability. Now the ratio of these two don't change anymore. So far so good. And then we said to figure out the concentration of reactant and product at equilibrium, we have to use equilibrium constant, which is product over reactant. It doesn't have a unit. And the magnitude of equilibrium constant will tell you which one is more favored. When you reach equilibrium, do you have more product, do you have more reactant, or they're equal? So far so good. And then solid and liquid are not part of the equilibrium constant. Yeah? Alright. Now today what we're going to talk about, we're going to talk about Q. Reaction So we're going to talk about Q and what Q is. So if you remember, K equilibrium or the concentration at equilibrium. Those are the concentration we have at equilibrium. Well, what if I don't know, have I reached equilibrium or have I not reached equilibrium? How would I know that? I have to figure out Q. Now, Q is based on the concentrations that I have right now in my reaction. So K was based on equilibrium concentration. When they reach equilibrium, those are the concentration. Now Q, you figure out Q based on the concentration right now. So if I have a reaction going on right now, I go, okay, so right now I have a reaction going on. I'm going to figure out Q. So far so good. So K is based on the concentration at equilibrium. Q is based on the concentration you have right now. Now Q is exactly the same as K. It's the same formula. It's product over reactant. And the reason that we do Q, because we want to know what's going on right now. We want to know what's going on right now. So the best way to do this, let's do a practice problem. So here is my reaction. I have N2 gas plus 3 H2 gas goes back and forth to 2 ammonia. And my Kc is 6.5. You good so far? Okay. Now, here's a question. Are we at equilibrium? And if not, what needs to happen in order to reach equilibrium? You follow me so far? So are we at equilibrium? And if you're not at equilibrium, what should happen for us to reach equilibrium? Okay. Now, every time they ask you, are you at equilibrium? What are you trying to figure out? You're trying to figure out Q, because Q is using the concentration you have right now. You guys are good so far? Okay. Now, in this problem, of course, they have to tell you the concentrations right now. So they say the concentration right now is N2 concentration is 0.500. H2 concentration right now is 1.00 molar. These are all molar, you guys know that. And ammonia concentration is 1.00 molar. Okay? Again, every time they ask you, are you at equilibrium? What are you trying to figure out? You need to figure out Q. Okay? You ready to do this? So the question is, are we at equilibrium? If not, what needs to happen for us to go equilibrium? You see that, you go, oh, I know that. I need to figure out Q. Q is the same thing as K. That means product over reactant. So then I'm going to have the concentration of ammonia to the power of 2 over the concentration of N2 to the power of 1 times concentration of H2 to the power of 3. So Q is exactly the same as K. Product over reactant, nothing we haven't done before. So let's plug this in. Ammonia is 1 to the power of 2 over N2 is 0.5 to the power of 1. H2 is 1.00. And the molarity, of course, to the power of 3. Okay? So when you plug it in, what you end up getting is 2.00. That is my Q. Now, what does that mean? So I got a Q. What does that mean? So every time they ask you, are you at equilibrium? You're going to use the concentration that are going on right now, and you're going to figure out a Q, which is exactly the same equation as K. Then what we're going to do, we're going to compare Q to K. If we compare Q to K, then we'll know what is going on in the reaction. Now, here are the possibilities. So what you have to do, you have to compare Q to K. Possibility number 1, Q is going to equal K. If Q equals K, what does that mean? We are at equilibrium. We are at equilibrium, right? We are at equilibrium. That's one possibility. Now, possibility number 2 is that Q would be bigger than K. What does that mean if Q is bigger than K? Think about this. So it's the same formula, product over reactant. If Q is bigger than K, that means you have too much of what? Remember, it's the same as before. It's product over reactant. It's product over reactant. So if Q is bigger than K, that means you have too much of what? Product or reactant. That means you have too much product. Exactly. Because that means that number is big. So if Q is bigger than K, that means you have too much product. Now, if you have too much product, too much P, which way would it need to shift in order to reach equilibrium? It would have to shift to the reactant, right? It would have to shift to the reactant in order for us to reach equilibrium. You guys follow me so far? Okay. Now, number 3. Q less than K. Again, is product over reactant, right? So if Q is small, that means I have too much reactant. So that means too much reactant to reach a stable state, to reach equilibrium. If I have too much reactant, what should it be? The equilibrium should shift to the product to balance it out. Work it so far? Okay. So every time they ask you, are we at equilibrium? You are going to figure out Q. Why? Because when we figure out Q, we can compare Q to K and then figure out where we are. If Q equals K, we're at equilibrium. We've already reached this stable state. If Q is bigger than K, that means you have too much product, right? That means you have too much product. So we have to shift to the reactant to balance things out, to reach equilibrium. Now, if Q is smaller than K, because you have to keep in mind, it's product over reactant, right? If you have more reactant, that's where Q is going to be smaller. That means you have too much reactant, and we have to shift to the product to balance things out. Okay? So these are the possibilities. These are the possibilities. So we figure out Q based on what we had. Our Q is 2. We're going to compare it to K. What is our K? 6.5. So what do you think? Are we at equilibrium? We're not at equilibrium. And Q is smaller than K. So if Q is smaller than K, I have too much reactant and we need to shift to the product. We need to make more product to reach equilibrium. That makes sense? Okay, nice job. Nice job. Yeah? All right. So again, the key is if you want to know if you're at equilibrium, if you want to know what's going on right now, figure out Q is the same formula as before, and then compare Q to K. And then compare Q to K to figure out what's going on. Compare Q to K to figure out what's going on. Okay, are you ready for... All right, now, how do we calculate? Actually, you know what? Let me give you a practice problem. Let's say we have A going back and forth to B, and my K is equal 1.22, okay? And what we have right now, we have 0.325 molar A, and we have 0.483 molar B. So far, so good. The question is, are we at equilibrium? If not, how can we reach equilibrium? How reach equilibrium? All right, I'm going to give you a minute. Pause me, do this, and then we're going to do this together. So, now that you unpause me, every time they ask you, are you at equilibrium? What do you have to figure out? You have to figure out Q, which is the same thing as K, is product over reactant. Now, in this case, it would be the concentration of B over concentration of A. And my concentration of B is 0.483. A is 0.325. Okay? So if I do that, what I end up getting is 1.49 is going to be my Q. Okay? I want to compare it to K. So 1.49 is my Q and 1.22 is my K. What can you tell me about my Q? My Q is bigger than K. My Q is bigger than K. So are we at equilibrium? We're not. Now, if the Q is bigger than K, again, remember, Q is product over reactant. If the Q is bigger than K, that means I have too much of the product, right? That means I have too much B. This is why this is a larger number. This goes up, right? Okay, so what that means is I have too much product. Now, what do we need to do to reach equilibrium? I have too much product. What can I do to reach equilibrium? To reach equilibrium, you have to shift to the left, right? So we have too much P. How do I reach equilibrium? To reach equilibrium, you have to go back to the reactant. You have to shift to the left. You have to form more reactant to stabilize and to reach equilibrium. That sounds good? Okay, that was it. That was not bad. It was a little short lecture. I'm doing a short lecture to make sure you understand how do you know if you're at equilibrium and what you need to do to reach that. Too much product, I have to shift to the left. I have to shift to the reactant so I can make more reactant so I can reach the equilibrium and stabilize. So far, so good? All right, nice job. Next time, we're going to do more practice problem. I'll see you next time.